Every day, millions of barrels of heavy black liquid are pulled from the earth. Most people imagine massive, cavernous underground lakes. They assume human engineers simply drill a deep hole, drop a steel pipe, and pump it out like water from a plastic bucket. This is a catastrophic misunderstanding of planetary geology. Underneath our feet, no such lakes exist. If you descend 3 kilometers straight down into the continental crust, you will not find liquid pools. You will find solid, impenetrable sandstone and limestone. The physical conditions down here are lethal. The static compressive load is equivalent to an adult African elephant, balancing its entire mass on a single postage stamp. Temperatures exceed 100 degrees Celsius. Under this violent thermodynamic matrix, pure water boils in a fraction of a second. A commercial plastic bottle would instantly liquefy. Yet, this is exactly where the oil is trapped. It does not flow as a subterranean river. It is permanently locked within billions of microscopic pores inside the solid rock, held hostage by severe capillary forces. It behaves exactly like a dense rock sponge saturated with heavy industrial grease. The planet refuses to let it go. So here is the terrifying engineering paradox. When over 90% of the Earth's most valuable fuel is hermetically sealed inside microscopic stone vaults, how do you forcefully extract a liquid from a solid stone that refuses to yield? Let me walk you through the violent mechanics of deep crust extraction, step by step. It begins with the mechanical breach. A heavy rotary drill bit violently pierces the sealed oil-bearing rock formation. This sudden penetration induces an extreme, localized pressure drop. Before the breach, the ambient subterranean pressure is 300 times greater than our atmosphere. Natural gas, heavily dissolved within the crude oil, is instantly depressurized. Obeying the fundamental laws of thermodynamics, the gas expands with explosive kinetic energy. It violently undergoes a phase change, generating millions of microbubbles. These expanding bubbles create a massive upward mechanical thrust. They physically push the heavy black liquid out of the microscopic pores, forcing it directly into the narrow steel extraction pipe. A violent eruption of gas and crude oil blasts toward the surface. This is the natural depletion phase. The planet is essentially purging the liquid out, requiring zero mechanical pumping energy from the engineers above. But this natural kinetic thrust is a temporary illusion. Within a few short months, the gas expansion energy rapidly depletes. The internal reservoir pressure collapses entirely. The microscopic gas bubbles lose their kinetic thrust. The heavy fluid stops moving, freezing in place miles below the surface. The upward flow dies. If the drilling crews simply walk away at this exact moment, over 90% of the heavy crude remains permanently locked underground. The solid stone matrix reclaims its hold. The natural physical forces of the Earth have completely zeroed out. This is where the true mechanical warfare begins. Engineers install massive steel pump jacks on the surface. These heavy, nodding mechanical giants attempt to suck the remaining oil upward. But this creates a fatal mechanical failure. Surface vacuum suction cannot overcome the locking capillary forces of the unpressurized microscopic pores. The physical resistance of the rock is simply too great. The pump jacks manage to tear away a mere 10 to 15% of the remaining fuel. The extraction well is essentially dead. To break the planetary grip, petroleum engineers initiate a massive hydraulic assault. They drill a secondary vertical shaft, technically classified as an injection well. On the surface, high-capacity industrial turbine pumps activate. They forcefully inject liquid water deep into the crust. operating at a pressure hundreds of times greater than the burst limit of a commercial truck tire. Every single day, a volume of fluid equal to 20 municipal swimming pools is rammed straight into the subterranean fault lines. This extreme volume of high-pressure fluid creates a massive hydraulic piston inside the solid bedrock. The water violently infiltrates the microscopic voids. It artificially spikes the deep crust pressure, physically displacing the heavy oil film and pushing it blindly toward the primary extraction pipe. It is a brute force mechanical displacement. But the Earth always finds a way to retaliate against this intrusion. Within a few years of constant hydraulic injection, the barrier dynamics begin to fail. The highly pressurized water naturally locates the widest tectonic fractures. It travels at extreme velocity, completely bypassing the dense, heavy crude. The massive subterranean hydraulic piston breaks down. Instead of yielding fuel, the primary extraction well begins vomiting a useless liquid, containing over 90% contaminated process water. The mechanical efficiency of the well collapses entirely. To counter this physical failure, petroleum engineers initiate a severe chemical assault. They inject highly viscous synthetic polymer solutions directly into the rock matrix. This dense fluid acts as a physical wall, brutally scraping microscopic oil droplets off individual sand grains as it forces its way through the microscopic voids. When mechanical friction fails, they weaponize thermodynamics. Liquid carbon dioxide is forced into the deep strata under extreme pressure. It triggers a severe chemical reaction upon contact with the crude. The kinematic viscosity of the heavy oil drops instantly. The carbon dioxide neutralizes the surface adhesion forces, liquefying the stubborn sludge and stripping it from the rock. If the deposit still resists, operators pump superheated steam at exactly 300 degrees Celsius down the shaft. This extreme thermal energy physically melts the crystalline structure of heavy paraffins and subterranean resins. The mobilized liquid is forced into the extraction pipe. These aggressive thermal and chemical tertiary technologies manage to strip an additional 30% of the trapped hydrocarbons from the stone. But extracting millions of tons of fluid mass from the crust creates a catastrophic structural void. The micropores are drained, violently disrupting the subterranean hydrostatic equilibrium. The static compressive load from the overlying rock strata remains constant. It presses downward with a relentless force, equivalent to 10 million loaded freight trains. Under this terrifying weight, the mineral framework of the sandstone permanently fractures. The entire oil-bearing geological layer flattens and crushes inward. This subterranean shear deformation slowly propagates upward, until the surface of the Earth physically collapses. In the extreme environment of the North Sea, the offshore Ekofisk field suffered this exact mechanical fate. Massive steel and concrete extraction platforms were firmly anchored to the seafloor in the 1970s. But by 1984, acoustic telemetry detected a severe structural anomaly. The ocean floor had subsided by nearly 4 meters. The abyssal limestone layer, located 3 kilometers down, had completely crushed under the weight of the ocean. Multi-billion-dollar platforms were actively sinking into the water. To prevent total structural destruction, engineers synchronized hundreds of powerful hydraulic jacks, physically slicing the massive steel support columns and raising the entire upper decks by 6 meters. On solid land, the mechanical consequences are even more violent. Extraction generates millions of liters of highly toxic industrial wastewater. To dispose of it cheaply, operators pump the contaminated fluid back down into deep tectonic fault zones. This pressurized liquid acts as an artificial hydraulic lubricant. It drastically reduces the natural friction coefficient between immense tectonic rock plates. The massive rock blocks lose their static grip, slipping and abruptly releasing terrifying amounts of tectonic kinetic energy. This directly triggers severe anthropogenic earthquakes. Regions that were historically stable are now violently fractured by hundreds of seismic tremors every single year. Today, this extreme extraction is governed entirely by precise cyberphysical telemetry. Acoustic impulses are fired 5 kilometers straight down into the continental crust. Subsurface sensors capture the acoustic reflections, rendering a highly precise, three-dimensional digital matrix of the fluid migration paths. Drill bits are no longer blind instruments of force. Using horizontal deflection technology, the heavy steel thread smoothly rotates exactly 90 degrees within the solid rock. It moves horizontally through the strata, much like bending the Ostankino Tower parallel to the ground at its base. Deep subterranean sensors monitor the internal pipe conditions every millisecond. If they detect water infiltration, microchips actuate automated subterranean valves. They hermetically seal the exact point of leakage within a fraction of a second, preserving the strict integrity of the hydrocarbon stream. This is not simply drilling a hole in the dirt. It is the precise, automated restraint of violent geological forces. Every single drop of extracted fuel represents a calculated victory over the absolute hostility of planetary thermodynamics.